Hello friends, in this lecture we will be discussing the functionality of physical layer and data link layer in brief. We know that we have to make the network efficient. To make the network efficient, we already discussed what are those data we are transferring, how those data are represented. We also discussed how the devices are interconnected. Then we discussed which rules are to be followed to transfer data. We discussed that there is a OSI reference model which has 7 layers. Those 7 layers are physical, data link, network, transport, session, presentation, and application layers. In this lecture, we will be discussing physical layer and data link layer. The function of physical layer is to transmit bits over medium. This is one functionality. The second is to provide mechanical and electrical specifications. So a physical layer takes data from the data link layer and converts these things into some physical signal format, transmit it to the medium, and at the receiver end, the physical layer will receive the data, convert into binary data form and give it to the upper data link layer. So it takes the data from the upper layer, converts into signal form and put it onto the communication link. So at the receiver end, it receives the same signal and converts it into binary data and gives it to the upper layer. Apart from these functions, the physical layer has to consider the following factors. What are those factors? Physical characteristic of interface and medium. What is the meaning of physical characteristic of interface and medium? If the medium is optical fiber, in that case, the signals should be in the form of light. We use laser lights. If the transmission medium is wireless, in that case, we have to transmit in electromagnetic wave. Okay. If the transmission medium is wire, we can use electrical signal. So depending on what is the medium, depending on the transmission medium, the signal form also changes. The second is representation of bits. How do we represent these bits? The bits, suppose 0, we want to transmit 0, 1, 0. I can represent this 0 as negative, positive, negative. So minus 5, plus 5. Okay, plus 5 represent this is 1, this is 0, this is 0. Other possibility is that I can represent this form. This is 0 volt, this is 5 volt. So how do you represent this binary informations? Whether we represent minus 5 plus 5, 0 plus 5, or whatever the way we want to, it should be. This is what is representation of the bits. Data rate, at what data rate we can transmit? If it is an optical fiber, the transmission rate can be very high. If we are using copper wires, the transmission rate will be comparatively low. Next is synchronization of bits. What is synchronization of bits? Sender is sending this bit pattern. Okay, and this is receiver. Receiver is also receiving this same bit pattern. Okay, so sender, assume this is the time periods, these are the time periods of the signals. When sender is sending the signal, the receiver should understand that this is the beginning of the bit interval, this is the end of the bit interval. And within this time, the value is higher, that means 1. Within this time, the value is lower, that means 0. For that purpose, what is required is the sender and the receiver should be perfectly synchronized. The receiver clock should know that this is the beginning of the bit interval and this is the bit duration. If their clock are not properly synchronized, then the receiver will not interpret correctly. For example, my class period is from 8 to 8:50 morning. Okay. One student is coming at 9 a.m. By that time, I shall not be available. So he will miss the class. Next day, when he came, he will tell, sir, I came yesterday, but you have not taken the class. You are not in the class. I told that you came between the class period. Yes, sir, I came. My watch was only 50-60 minutes late. Oh, your watch is 60 minutes late. That means you came at 9 a.m. Then this he will tell the student will tell that yes. So if you want to attend my class, so you have to synchronize your clock with the institute clock. Then only you can come to class and attend the class. Otherwise, it will not be possible. If you will come, you can get a class, but that will not be my communication network or data communication network. It will be some other course. You will not get the correct information. Similarly, here also, if the receiver clock is not properly synchronized with respect to sender clock, then whatever information they will get, that is not correct. So it is very much important that sender and receiver must be synchronized. This functionality is taken care by the physical layer. Next, physical topology. Which type of topology we use, that also is part of the physical layer. We discussed various topologies, that those topologies are bus topology, star topology, mesh topology, etc. Those are the physical topologies. Which transmission mode, whether there is transmission is half duplex, full duplex. Okay, we understood the basic functionality of physical layer. Details we will discuss in later chapters. Now we'll move to the next layer, that is the data link layer. The function of data link layer is to organize bits into frames and to provide node-to-node delivery. So data link layer takes data from the network layer, add header and tailer, give it to the lower layer, that is the physical layer. At the reverse side, at the receiver end, this takes data from the physical layer, removes this header part and tailer part, this is tailer part and header part, and give it to the network layer. Let us understand what is the meaning of organize bits into frames. That is framing. How a system can distinguish between idle bit pattern and data bits. What is the meaning of this? Suppose my data transmission is 1010101. Okay, so this will be represented by 101011101, right? And after that there is continuous blanks, zeros are there. So there is no more data are there. So this is what is sender is sending. Now when the receiver is receiving, so these things will be received here. Now this receiver will treat this part as 0 or silent. How it can know that the data is transmitted between this point to this point, not beyond that? Understood? So this is what is how a system can distinguish between idle bit pattern and data bit pattern. So the receiver is having a confusion whether those continuous 0 is actually 0 that is sent by the sender, or that's the idle bit pattern, nothing is sent. So that need to be understood. How it can be done? For that purpose, framing is done. So every packet is preceded and followed by a special bit pattern such as this. So every packet will have beginning this pattern 01010101, and the end of the frame also it is having 01010101, which each system monitors for the beginning and the end of the data. So the receiver will be looking to this bit pattern. When it finds out this bit pattern, understands that, oh, now next bits whatever is coming is the frame bits. When the frame overs, again it find out this bit pattern, then it understands that, oh, this is the end of the frame. Okay, so this is what is called the framing. That is why data link layer adds in the beginning. So whatever data link layer will be receiving, this is what, let us say, from the network layer. Along with that, it will add header and as well as tailer. Okay, in this header, along with the other things, this specific bit pattern 01010101, here also the same bit pattern will be there. will be there. Okay. The insertion of this type of marker in the bit stream is called as the framing. This is what is called the framing. So the receiver can understand, make out when is the beginning of the frame, when is the end of the frame. The function of data link layer is to organize bits into frames, which we discussed now, and to provide node-to-node delivery. So in a network, we'll have a source, we'll have a destination. To deliver the source, the packet from source to destination, it provides the address called as the physical address. So to send the data from source to destination on the network, the data link layer adds a header to the frame to define the physical address of the sender and receiver. Both sender address will be there as well as receiver address will be there. For example, so sender is, let us say, 10 and receiver is 87. So when a packet is sent, we can see in this packet we'll have a header as well as tailer. Along with, we'll have a source address and destination address. Okay, source address is 10 and destination address is 87. So physical layer takes care of sending the packet from source to the destination, provided this is within the network. On the network, you can see these 5 computers are present in one network. If the frame is intended for a system outside sender's network, the receiver address is the address of the device that connects one network to the next network. If you see, we have a bigger network or internet, which is a connection of networks. In that case, what happens is that if a source is in one network and destination is in another network, which is outside sender's network, the receiver address is the address of the device that connects one network to the next. See here, there are 3 networks are there. This is the top one is a bus topology network. This is a ring topology network. This one another bus topology network. Assume we have A. This is A. Want to send data to P. This is what is a P. Okay, this is P and this is P, which is outside the sender's network. What will be the physical address? So A want to send to P. P is outside the network. What will be the physical address? So in this case, what will be happening? The source address will be the physical address of this is source is 10, and the destination address is the device, the physical address of the device which is connecting to the outside network. So this is a device, this is called as a router. This router is connected to the upper network with address 20. This is the physical address of this device. So the destination address will be 20. That's how we can see 10 and 20. We'll see this what is A and P. So source address is 10, destination address is 20. When this packet will move out from here, this will have packet, let us say, will have source address as 31, let us say. So 31 is the source address. Destination address will be 33. When this will cross across here, the source address will be 66 and the destination address will be 95. Okay, every network, every local area network, the physical address will be changing. Some other functionality of data link layer. What are those? The flow control. So we discussed that the data link layer is responsible for transferring data between the nodes who are present in a network. So when 2 devices are communicating, at what rate they will communicate, that is the flow control. If one device will transmit at very high speed, the other is not ready to receive, then it will be difficult. So in a class, if a teacher is teaching is moving very fast and you are not able to receive it, then what will happen? It will be overflow. So the teacher and the student should be in proper synchronized manner. Whatever teacher is teaching, the student should be able to understand. If student are not able to understand, then the teacher should make it slow. So that is the concept of flow control. Here it is done between source and destination is inside the network. It is a set of rules that enables a data source to match its transmission rate to the currently available service rate at the receiver and in the networks. So looking to the receiver and the network, the data rate should be matched. Error control. So when a transmission of data from data link layer adds reliability to data transmission by adding a mechanism to detect and restart transmit damaged or lost frames. So when we are transmitting a frame, there is possibility that that frame got damaged because of any problem. It may happen. So in such case, the receiver should be able to detect there is a problem. Then it should request for retransmission. That is called as the error control. Access control. If we have a wireless medium and there are 5 terminals, 5 people are having laptops, all of them want to use internet. All of them want to use the network. So what will happen? It may be possible that same time 5 people will be transmitting. Then what will happen? It will be collision. Like in a class, there are 10 students. All 10 students want to ask to a teacher same time. There will be collision and teacher cannot understand. So what teacher will tell? Hello, just ask one after another. This is what is a controlling mechanism. Similarly, in a wireless medium also or in a network also, that should be a control mechanism so that the collision can be avoided. When 2 or more devices are connected to the same link, data link layer determines which device has the control over the link at end. So these are the basic functionality of physical layer and data link layer we discussed in this lecture. We'll discuss the functionality of other layers in the coming lectures. Thank you. If you have any queries, please write in the comment box, or if you have any suggestions also, please write down. Thank you.